Hi everyone, welcome back to our YouTube channel. I'm very sorry about the glitch. So we've managed to get Yusuf reconnected nicely. So we'll now hand over the platform to him so that we can see him do a demonstration on the real robot, and we'll get into his presentation as we go. So I'll now give him this floor so he can begin. Okay, Yusuf, whenever you're ready.
Yes. Good afternoon. I'm Yusuf Solomon. I just finished the Python 3 for Robotics course and the Linux Basics for Robotics course, and I am here to present my projects on those courses, starting with the Python 3 for Robotics course.
Okay.
The this is the real robot, and I have connected to the real robots just to do a quick check. ROS topic lists. Yes. And now to run the actual code. Let me get the, the yes, just got the commands, and here, okay. Robot is not connected. It's not moving.
Um,
Looks like the robot is not connected.
can you try disconnecting and connecting again to the real robot?
Let me try that.
All right.
Uh-huh. Connecting again.
Okay.
Connected.
Okay,
Okay.
let's start by doing using a teleop twist teleop pad to see if it moves. I see.
The joysticks aren't even.
All right, can you run a teleop command to see if maybe if you can use your keyboard
Yes.
to move it?
Yes, that's yes. Doing that. Okay. Turn up command is not working.
Still not moving.
Yes. I
Uh,
want to try to refresh the page.
all right, do so and let's see.
Escape. That is going on. Okay.
Mm,
Still not.
Still not moving.
Yes. And everything is connected properly.
Can you just see if you've got all the topics
Yes.
being listed? Just
Okay. No.
okay. Okay, I see. So
These aren't all the topics.
all right, all right. Why is it not loading? Okay, let's get into your code for now, and then we'll retry later. Okay.
Okay.
Did you prepare any slides, or you just gonna be going through
Right.
one flow
Just
at a
wanted,
time?
yes, I just wanted to explain the code.
Okay. All
Didn't
right.
prepare any slides.
Um.
ID is loading.
All right.
Let me try to open it here.
Okay.
Okay.
Mm-hmm.
Okay. Okay. Starting with the no class. So in this approach, procedural programming approach, all I did was define a lot of functions. Here we have the sample move function,
Mm-hmm.
and this one sets the linear velocity of the robot underscore interface class
Mm-hmm.
that was imported here, and it sets it to the given linear and angular velocities.
Mm-hmm.
So if it is 0 and 0, set it to 0 and 0. If it is 1 and 1, set it to 1 and 1.
Mm-hmm.
Now these are the robot movement functions. The get linear and angular velocity. This get returns the linear and angular velocity of the robot class. That is here. This gets the linear velocity and this gets the angular velocity, which are both attributes of the robot interface class.
Mm-hmm.
The stop robot, this one sets the linear and angular velocity to 0, stopping the robot's movement.
Mm-hmm.
This move robot front, this one moves the robot based on the speed that is given in the function. This is the speed here, and it moves the robot forward. That is sets the angular velocity to that particular speed.
Okay.
And the same thing for the back, but it sets the angular velocity to negative of the speed, so it moves backwards instead. Now we
Do you mean
have the
angular
top.
velocity or you mean linear velocity? Because I see it says linear velocity there.
Yeah, sorry, linear velocity. That was
Okay.
the mistake. Linear velocity sets it to negative of the speed, moves it backwards.
All right.
Now, turn robot left sets the angular velocity to the particular speed, angular velocity speed,
Uh-huh.
and turns the robot left. That's positive. And for the right, would have negative of that speed. So set angular velocity speed, set angular velocity to the negative of the angular speed that is given in the function.
Mm-hmm.
Now, this is another function that is turn robot left, but it is based on time.
Mm-hmm.
So we feed in to the function, we feed in the angular speed and then the time. So it sets the robot to this particular speed using this function that has already been called up here.
Mm-hmm.
Sets the robot to this particular speed for the amount of time that has been fed into it. So when the time is over, let's say 5 seconds,
Mm-hmm.
the robot stops. The
So
stop
you're
robot
defining a
function that
function that calls another function.
yes,
All
the
right.
function calls another function.
Okay.
Same thing for this turn robot right, uses the time turn robot right. This is the turn robot right function, and then it sleeps for a particular time, and then the robot is stopped.
All right.
Now, this is move distance front. This is just like the move forward function, but it is based on speed and distance. So we give it the particular distance in centimeters we want it to move forward.
Mm-hmm.
Let's say 5 centimeters at particular
Okay.
speed. Let's say 5 centimeters per second.
Yes.
And based on this speed and distance, the time that the robot should sleep is calculated. And here it is distance over speed, speed being distance over time. want to get the time to be distance over speed,
Okay.
and this is the time that robot will sleep for, and then the distance that has been fed will be traveled in that speed for this amount of time, and then the robot stops. Same thing for the back. We calculate the sleep time that we need by dividing the distance by speed
Mm-hmm.
and setting the move robot's speed to the particular speed that has been fed into that is an input parameter into the function. Now,
All right. So
turn
can
angle
you
left. This is like the
okay? Can you explain a little
yes
bit what why do you need to make it sleep? Right. I want to understand the logic behind that.
behind the sleep.
Mm-hmm.
Yes. So in the robot, where we are setting particular parameters, like the linear speed parameter,
Mm-hmm.
inner velocity parameter, we are setting to a particular value. So the robot now has a linear speed of, let's say, 0.1 meters per second.
Mm-hmm.
So that means every second it travels 0.1 meters.
Mm-hmm.
That is, so that's what we're setting it as. So if we wanted to travel 0.2 meters,
Mm-hmm.
we would let it have the 0.1 meters per second speed for 2 seconds.
Mm-hmm.
So letting it have that speed for 2 seconds, we let it travel 0.1 meters twice,
All
zero
right.
point 0.1
All
meters,
right.
and then 0.1 meters. That's 0.2 meters.
All right.
Yes.
I do understand that bit. What I want you to get to is why are you making it sleep? It's like uh, what is it that is happening in during the course of running that code that you are stopping from?
Sleep.
Yeah.
Okay. Right. Okay, yes. The sleep command just delays the code, the running of the code. So nothing runs during that sleep time. And when the sleep time is done, the next line runs.
Okay. All right. Wonderful. Okay. Let's go on.
Yes. Now turn angle right 2 does the same. Now the laser scanner function. These functions gets data from the robot, from
Mm-hmm.
the laser sensor of the robot. So it's getting the data from the robot. So it just returns that particular data. This gets minimum scan angle. We have the we already have the variable scan angle min,
Mm-hmm.
and get maximum scan angle. We already have the variable scan angle max. Um, get angle increments. We already have the variable scan angle increments, and so on, so on. Now for the get front scan angle.
Mm-hmm.
So to get the front scan angle, we know the front angle would be in the middle of all the ranges. So we'll get the middle of the scan ranges
Mm-hmm.
by divide floor division of 2
Mm-hmm.
to get that middle index. Once we've gotten that middle index, we would feed it into would get the particular index from these scan ranges.
Mm-hmm.
So we put scan ranges, this particular middle index, and we'll
Mm-hmm.
get the front scan range.
Mm-hmm.
Same thing for the back, but the back would be an addition of floor division of 2 and the floor division, another floor division of 2, which will give us the back scan range. And then when we've gotten the index with this back index variable, we'll feed it into the scan ranges to get the index at that, to get the value at that particular index.
All right.
And that is what is fed into the
All right. Can you tell me what data structure
yes,
you're using there? Right. What Python data structure are you using for your ranges data? Right.
it's a list. It's a Python list.
Okay. So that's the one with the square brackets. Is that right?
Yes.
All right. All right. And how would you differentiate it from a tuple, for example?
How would I differentiate it from a
From a tuple.
didn't get that.
The tuple.
Tuple. Yes. The difference between a list and a tuple is that a tuple is immutable. We cannot change the indexes of a tuple. We can index them, we can get particular indexes, but we cannot change them. We
All
cannot
right.
change. It's immutable. It's an immutable data structure. But a list, we can change a list. We can add values. We can remove values. We can exchange values,
Uh huh. Uh
and
huh.
we can also index them and get particular indexes.
Just like the
Yes.
list. Okay. So what's the syntactical difference between the two?
To define a tuple, we would use parentheses
Mm-hmm.
like this, and to define a list, we use square braces like this.
All right. All right. That's good. That's good. Let's go on.
Yes. So same we do same concept for the left scan range and the right scan range. Now, to get the minimum range without infinite values,
Mm-hmm.
we first get we first define this as so this variable is now infinite, and now we would loop through everything and make sure that the value is not infinite.
Mm-hmm. Okay.
If the value is not infinite and it is lower than the minimum value, that value is our minimum value. And we'll loop through, continue like that until we're at the end of the list. And the value that we have as the minimum value at the end of the list
Mm-hmm.
is the minimum value. We store that with the index of that particular value.
All right.
Same thing, same logic goes for the maximum range with infinite. Now we have the odometry function. The odometry sensor is used to get the position of the robots in space. We have the X, Y, and Z positions, and we also have the roll, pitch, and yaw positions.
Mm-hmm.
So that is what is happening here. And I am returning the values as a dictionary here,
Mm-hmm.
with X as a key, and particular position of X as a value. Same thing with rule R as a key, and a particular reduction R value as the value.
Mm-hmm. Okay.
And
Okay.
now we have the okay.
Go ahead. Go
You want to
ahead.
ask a question?
No, I was agreeing to what you were saying, so it's fine.
Okay, thank you. Now the equidistant distance, the formula was provided in the project for calculating the equidistant distance, and that is what is used here.
Mm-hmm.
We feed in four values: x1 and y1, which is the original position, and x2 and y2, which is the current position, to get the distance between the current position and the original position. That is what this function does.
All right. All
Now
right.
the IMU function is used to get angular and linear angular velocity and linear acceleration. We also have different we have the x on the x-axis, on the y-axis, and the z-axis.
Mm-hmm. Okay.
Same thing for the angular velocity on the x-axis, y-axis, and the z-axis. Now, this is my text function. This is a very bare minimum function that just calls all the functions that I have defined. So
Okay.
here we have putting the original linear and angular velocity, and now we want to call this move robot front function, which moves the robot front with this speed
Mm.
and then sleeps for 5 seconds, delaying the program to let the robot move at zero point 0.2 meters per second for that 5 seconds. And then movement sprints in the movement is stopping the robot, and then we stop the robot, which sets the linear and angular velocity to zero,
Mm-hmm.
and then we sleep for another 5 seconds before we move back, sleep for another 5 seconds, then we turn left with an angular velocity of zero point 0.5 for 5 seconds, and then we turn right 0point 0.5 for 5 seconds, then we sleep for 5 seconds, and
Right.
then we stop the robots. Then we're now using the move distance front. So this function moves the robot at a speed of zero point 0.2 for for a distance of zero point 0.2. And so this would actually run for 1 second because of distance, and time is equal to distance over speed, to get the particular time that would take to move this zero point 0.2 centimeters.
Mm-hmm.
And that happens. And after that happens, we turn the angle. I run this function that turns the angle left, feeding in the angular velocity and then the angle that we want. So this the angle that we want is 45 degrees. Let me say yes, 45 degrees. So we move. So this is the value in radians that is fed into it. So then the speed that is required for that, the time that is required for that will be calculated. It's calculated inside the function, and the robot does what it is set to do and stops the robot. Now we're printing the different laser data that we have gotten from the sensors. The get scan angle, maximum angle, increment and all this. Now we're getting all of the ranges. And I noticed from the output of this code that the ranges, we have 660 range scan ranges.
Mm-hmm.
So for a yes, so we have 660 scan ranges. So this middle will be 330. That's the front. So
Mm-hmm.
330 is in front. And this was what I used to be able to get which particular angle is in front, is on the left, and is at the back,
All right.
which
All right.
I implemented in my class code. So then these are all the remaining functions that are run. This gets the IMU data,
Mm-hmm.
and this that is the entirety of the functions that were defined for this new class.
All right. All right.
And
Can you
yes,
a very very nice detailed run through the code there? Can you at least try to connect or check if the robot is responding yet, so we can do the demonstration of your code there? Just maybe refresh everything and let's do it again.
okay, okay, okay. I mean the okay. Run the teleup command again.
Okay.
Still not connecting.
Mm.
Let me retry that. Let me disconnect and connect.
Okay.
I have run this thing before. I don't
Mm.
know why
Yeah.
I'm
Yeah.
having problems now.
It does happen. It does happen now. But don't worry. We'll try to check what might be going on there.
Okay.
Try using the telop commands instead, because I think the gamepad is not connected. So
Okay. Let me get the command. Let me run this first.
all right.
Run two instances. The same thing. Okay. Thing is still happening.
Mm, try rotating it. Let's see. You're making it rotate in place. Yeah.
It's not receiving commands. Let me check.
This one.
Box here.
Yeah.
Connect box here.
Try rotating in a place in that terminal, and let's see.
In the term.
Yeah, using
Okay.
the tail of keyboard. Yeah.
Okay.
No response yet.
No response yet.
All right. So it's fine. Since you have been going through your code, do you still have things you want to talk about, or that was all?
Yes. Yes. For the Linux one, I
All
need to
right.
open
We will do that
the ROS.
in a different broadcast. So let's wrap this one up, and then we'll get to that one immediately after. Okay.
Okay.
All right.
So
Sure.
I'm reopening the.
Yeah, it's fine. You can
Um.
get it loaded. Let's just wrap up here, and then I will be with you soon. Okay.
Okay.
Sure. All right, everyone. So this was Yusuf's presentation. It's unfortunate that he couldn't get to run it, but we'll do our best to get him to run it. Okay. And until next time, we encourage you to keep pushing your ROS learning. To those who would like to try the courses we offer certification on, we highly recommend you do so, and you can come and do your presentation to prove your understanding and also show us a little bit more of what you might have to enhance the projects. All right. So